Howdy, y'all, and welcome to our course, Databases Demystified, sponsored by Fivetran. I'm your host, Michael Kaminsky. Welcome to Databases Demystified. This is our first lesson for folks looking to go deeper on understanding databases. We're going to, at a very high level, talk through the history of databases and some of the most important terminology and different types of databases that you might encounter. If you're already familiar with databases and you're ready to get into the meat of how these databases work under the hood, or focus on more advanced topics, feel free to skip ahead to the other episodes. If you're newer to databases, in this lesson, we're going to give a 30,000-foot overview of the most important terms and concepts in order to get you oriented to the lessons that will come later. Databases are super important. They're really fundamental to how we use computers. They allow us to save information over time, even if we turn the computer off. They persist the data that we need in ways that are convenient for both humans and software to access and analyze them. There are databases under the hood of lots of different software applications that you use. Any website that has a login probably has a database somewhere in the background. Facebook, Google, any e-commerce store all rely on databases. There's an important piece of terminology here that I want to call out. Here, we're really talking about database management systems, or DBMSs. We'll be using the shorthand term database to refer to these systems throughout the course. I want to cover a brief history of computing just to give you some context on how these tools were developed over time. When computers were first developed, databases as we know them didn't exist. For a while, there wasn't even any durable storage at all. If you turned the computer off, you would lose any data that you had input or created. You could imagine computers that operated on reams of magnetic tape, where the data was organized in a custom format for a single-use application. In the 60s, people realized that data stored in a general, structured way would be really convenient, and they started developing proto-databases following this line of thinking. In the 70s, things really took off with the invention of relational database management systems and the invention of SQL. This was where we started storing data in tables, and that really unlocked the ability to do way more with computers than what people had even imagined before. It'd be difficult to overemphasize how important this development was in the history of computing, as relational databases still underpin a huge amount of the internet and the computing infrastructure that we use every day. In the 2000s, as the amount of data that we wanted to store started to increase rapidly with the growth of the internet, there was a lot of development in NoSQL and big database technologies to be able to build fast software at a massive scale. In the 2010s, there was a lot of development made on MapReduce and massively parallel processing. After we stored so much data in the 2000s, we needed infrastructure for analyzing all of that data. Hence distributed computing to be able to process all of it efficiently. Today, there's lots of really interesting technologies that are being actively developed. I'm particularly interested in some of the new streaming databases that are optimized for analyzing data as it's coming into the database. There's also some really cool application-specific databases that are being developed that are designed to work very well for very specific use cases, like a time series database. And those developments are really exciting too. Databases are a topic of technology where we're going to continue to see lots of investment and lots of development into the future. When I think about databases, it's helpful for me to think about some of these broad categories. Anytime I encounter a new database technology, I'm thinking about where it fits in these different paradigms in order to understand what types of use cases it's optimized for and where it might run into difficulties. These topics are all very important, and they provide a roadmap for what we're going to cover in this course so that you can understand what these terms mean and the different types of trade-offs that are made when working with these different databases. We're going to dive deep into each of these different topics and why they're important in future lessons, but today we'll just be giving a high-level overview. A key paradigm for databases is analytical versus transactional. In an analytical world, you might be analyzing large amounts of data. Maybe you're an analyst or a data scientist that's really focused on answering business questions through analysis. But in a transactional world, you're managing state for software applications. You're keeping track of which users are logged in, which users are logged out, which orders have or haven't been shipped, things like that. Those are fairly different use cases. And we see lots of databases that are optimized for one or the other. We see data warehouses like Redshift, Snowflake, BigQuery, or MapReduce data stores like HDFS on the analytical side. And on the transactional side, we have technologies like PostgreSQL, MySQL, Oracle DB, and Microsoft SQL Server. Relational and non-relational is another really important concept in databases. In a relational database, data are stored in tables that can be joined together. One table relates to another, and a user or an application can follow those relations to get to the data that they want out of the database. In non-relational databases, the idea of having different tables is much less important. Data are generally stored in one big blob in things called documents, which don't necessarily have a fixed schema or shape. In one document, you might have one set of attributes, but in another document, you might have a different set of attributes. Relational databases are probably the most common. And here we have databases like MySQL, PostgreSQL, and all of the data warehouses. On the non-relational side, we have tools like MongoDB and Redis, amongst many others. This is another really important concept that we're going to dive deep on in future lessons. Distributed databases are really important to understand because with today's technology, it's critical to understand distributed computing in general. In a distributed database, the data are distributed across multiple different computers or servers that make up the database. So you might have part of your database in a data center in New York, and another part in California, and then another part on the other side of the world. This is in contrast to a single node database, where all of the data are stored together on a computer or server. These are much easier to reason about, but less fault tolerant and less powerful computationally. This is a place where there's been a lot of development in recent years. On the distributed database side, we've got tools like Google Spanner and Azure Cosmos, plus all of the big data warehousing technologies. Whereas on the single node side, you've got your traditional databases like PostgreSQL or MySQL. For in-memory versus on-disk, this describes how the data are stored or accessed by the computer. In-memory, of course, referring to RAM, while on-disk refers to permanent hard drive storage. If the entire database is loaded into RAM, the database can be very fast because reading data from disk is the slowest way of accessing data. However, if the database is saved on hard disk, it's going to have more properties like the ability to store more data, since computers tend to have more hard drive space than the RAM, and also less risk of losing data if something goes wrong and the program crashes. Some popular in-memory databases are things like Redis and MemSQL. And for on-disk databases, we've got our familiar set of traditional databases and data warehouses, as well as many others. So we can't have a lesson on databases without talking a little bit about SQL, which stands for Structured Query Language. SQL is a language for interacting with databases. Some people find it really intimidating. It's definitely different than a lot of other programming languages that people have experience with. I personally find it really fascinating because it's a declarative programming language, which means that you have to describe to the database the type of output that you want, and then the database itself is in charge of figuring out the best way to get you that output. People tend to refer to SQL as one thing. And there are, in fact, ANSI or ISO standards for what SQL should look like. But in fact, the way it's implemented for every database is a little bit different. If you've used SQL in one type of database, probably 90% of the things will be the same in another. But there will be these little differences, and every database has its own unique flavor of SQL that it uses for doing different types of operations. It's not a huge thing to overcome once you're familiar with SQL, but it is good to know that you can't just take a query from PostgreSQL and expect it to work right away with a MySQL database. There's going to have to be some amount of translation or transliteration between those two technologies. Also, it's important to note that not all databases use SQL at all. Redis, for example, doesn't have a SQL interface. We'll have a whole lesson on SQL in the future, but this is generally what it looks like. You might have seen some of this before. Here we see that within SQL, there are different types of operations. We have DDL, or data definition language, that tells the database about the types of things we want to store, creating tables, specifying column types, things like that. We also have the data query language, which is how we describe to the database what we want from the database. And both of these types of operations, plus many others, are all valid SQL. And that's it for today. This was a really broad overview of lots of the different important concepts in databases. We hope that you're going to stick around. We hope you'll check out our other episodes. And you should definitely like this episode and subscribe to our channel to get alerts on future episodes as they come out. This was just a little taste of the things that we're going to be talking about. In future episodes, we'll be really getting our hands dirty with these underlying concepts to give you a robust understanding of how and why these databases work the way that they do. If you have questions, comments, thoughts, or ideas, please drop them in the comment section below. We'll see you in the next one.